In this video, we'll talk about certain issues with this answer. Alright, and then we'll also go on to part B of the answers. Alright, hopefully you can clear them in this video. So the equations for this one that we have derived earlier is this one, right? The tsai hill type of thing. And we use this to actually find our so-called factor of safety, alright, or safety factor. And we get this thing. But if you think about it, the equation, alright, very important concept. Alright, I don't know where I stop also, but we lose out something that is within this equation, that is equals to 1 over f square. Alright, so we know that our thing is safe because it's less than 1, right, from the PDF equation, right, or the equation over here. Alright, so this thing over here, if you're larger than 1, this means you're unstable, right? Alright, so it predicts the failure if the magnitude of the stress reach the following condition. So if it's larger than 1, then the failure will start to occur. Alright, so if you are lower than 1, you are pretty safe. Okay, so from the lecturer's equation, alright, their values is actually 0.245. Alright, and this is the most important thing, is must be equals to 1 over f squared. This is the factor. Alright, so for our case, if you were to calculate for this, alright, 0.28 is equals to this thing. So the factor for our case is 1.87. Okay, so if you use the lecturer's value, which is 0.245, you'll get 2.05. In fact, it's 2.01. Okay, but somewhat you get to see that the link or the key thing is this equation. Alright, and in fact it's actually this part 1 over f squared. Alright, where the lecture notes aren't given to you. And go to the notes over here. Alright, you see it's also given as a larger than 1 thing. So it should be equals this calculation should be set as equals to 1 over f squared. Alright, in order to calculate our factor. And this is a very important thing you should take note of. Alright, and the part B tells us that also use the maximum stress failure theory to determine the minimum factor of safety of the first laminar against transverse stress with that obtained from the tsai hill theory. So what is it talking about now? Alright, so we are entering into the part B of our question. So this is something that we didn't actually go through also. Alright, but I think is pretty also interesting, is that the factor itself. Alright, the factor is equals to your x, strength in the x direction, divided by stress 1, or absolute value of the stress 1. So this is actually the stress 1, right, because it's in the 1 direction. Alright, this is the 2 direction, this is actually the stress 2. Alright, this is stress shearing. Sorry, my fault. This is give me a while. I don't know where am I again. But anyway, the question itself is trying to ask us to use the max stress theory to find our minimum factor of safety. Okay, and then we have to use the maximum stress theory, the value of the factor of safety, to compare it with the tsai hill theory, right, which is the one that we've obtained, 1.87. So we're going to compare these values, and then we see and comment on. So we have to compare the level with that and give a certain comment. Alright, and therefore what we do is to get the max stress theory equation. Alright, and the factor of safety is equals to x divided by sigma 1. Alright, y divided by sigma 2. Alright, and then s divided by tau 1 2. Alright, this is an equation that is not given to you anywhere also. So please take note that this is very important. Please remember in your heart or whatever thing that is. So what is x? X, if in the previous video we have defined it as 600 MPa, s, all the values are all here. And sigma 1, sigma 2, sigma, in fact this should be tau 1 2, sorry. Yeah, this should be tau 1 2. Okay, your stress 1 2. Alright, so with all this, you can just sub it in. Alright, because if I was to just bring this value down here, think about it. Alright, we have all the values now, right? So x is equals to 600. So 600 divided by sigma 1, which is 69.45, because it's absolute value. So I will have 0.63. Alright, so the y now is 60 MPa. So I'll just simply sub in only. I'm just simply subbing the stuff. Divided by sigma 2. Alright, which is 28.05. And I'll have 2.14. Okay, and if you were to calculate for the shearing, alright, shear is what? S is 50. Alright, 50 divided by 12. Okay, so if you were to get that, 50 divided by 12, it's 4.17. Okay, and if you were to take a look, the minimum factor of safety, the lowest one is actually 2.14, which is in the transverse direction. So far what we have been doing is to get the factor of safety for each of the scenario. Alright, so for this one in the x direction is the factor of safety when you were to pull in this direction, and therefore it's the strength in terms of x divided by stress 1. Alright, so it's the factor of safety against that. Y, this equation is the y-axis, the strength in the y direction divided by stress 2. Okay, hopefully it's pretty clear. So it's the strength of the material against the stress. Strength of the materials against the stress, I repeat. Alright, so the stress is the input stress. So this one is the material strength. So if you take a look, your strength, it's 2.14 higher than your input stresses. And this is the minimum value. Alright, so it's the factor of safety for here is very low. Alright, so the lower you are, alright, the dangerous you are. Alright, so over here 2.14 is still okay. Alright, typically I think 3, I forget already. Anyway, so if you were to compare this value, our 2.14 with our Tsai theory, which is 1.87. Alright, if you think about it, our Tsai theory is much conservative. Alright, meaning it's more how do I say? It's more stringent, you see, because if you were to use this formula, alright, as you can see, your Tsai theory, the factor of safety is much lower. So you know it's much lower, you're gonna adjust your strength. You're gonna choose a better material now, as compared to this one. This one 2.14 still okay. So if you want a factor of safety of 2, then straight away you can carry on with things. But carry on with things given that you use the maximum stress theory to determine your factor of safety. If you use the Tsai theory, you will fail the factor of safety, and therefore you have to change your design or change your so-called strength of material already. So this is the comment that you're gonna mention. Alright, so over here the lecturer write the max stress theory give more conservative factor of safety against failure. I believe, isn't it more lenient? I think that the max stress theory is more lenient than the Tsai theory, because given this calculation you get to know that your factor of safety is higher, right? So you think that it is actually higher, but in fact it's lower if you were to use the Tsai theory. Tsai theory calculate using the same amount of stress, you derive a lower factor of safety for your design. So therefore you want it to be, so this is more stringent, if I were to say that. Therefore I'll leave you to think about it. But generally the equation over here is pretty much very important. So I would want you to memorize for your Tsai theory. Your max stress theory. And in fact actually this comes from your this thing over here. Your ultimate strength divided by the working stress give you a factor of safety. And in fact this belongs to your what do we call, to your max stress theory. It should belongs to the max stress theory if you were to calculate for the factor of safety. So this thing over here should belong to your maximum stress theory. Alright, so these are the things that you may want to take note of. Alright, and I think it's pretty helpful. Yeah.